move on to Chapter 4, Congruency and Similarity. So in Sec 2, we have this topic before, and we have learned the definition of congruency and similarity. So in Sec 3, you're supposed to know how to prove congruency. So you learn this 4 tests: SSS, SAS, ASA, and RHS. So first of all, congruency means that two figures are exactly the same in terms of corresponding lengths and corresponding angles. So let me go through them one by one. First of all, SSS. And in this figure, they show you two triangles where AB, and they state that AB is equal to AC, M is the midpoint, angle ABM is 60 degrees, and you want to show that ABM is congruent to ACM. So in part A, the best way to prove now would be SSS, because AB is equal to AC. This is due to the fact that they are the sides of the isosceles triangle. And BM is equal to MC, because M is the midpoint. And lastly, AM is the shared, or you can say common, side. So AM is a side in both triangles, so naturally it's the same. Therefore, by SSS, these three sides, we have proven that triangle ABM is congruent to triangle ACM. Part B, you want to find angle Y. Since we have already proven that they are congruent, angle Y is equal to angle ACM, right? That's another name for angle Y. And by looking at the name ACM, you should go for the corresponding angle ABM. Is equal to angle ABM, which is equal to 60 degrees. So this question is simple because they give you part A where they tell you that you must first prove that they are congruent first. But if they want to make it harder in exam, they will not give you part A and part B. They will just throw you this question and say, go for angle Y. So for the people who did not prove congruency and they go straight to tell me that Y is equal to 60 degrees, it is wrong. Because you cannot just assume that, they look like congruent triangles, so they must be congruent. Okay? You must first prove that they are congruent triangles. Now for SAS, take note that there is a significance in why I call it SAS. Okay? So this angle must be between these two sides. So I'll explain what I mean in this question. First, you want to find a triangle that is congruent to ABC, right? So let's see what we know. We know that AC is equals to DC, because these two sides are the same. We know that BC is equals to CE, right? And since these two are straight lines, AE and BD are straight lines, we also know that angle ACB is equals to angle DCE because of vertically opposite angles. So therefore, by side, this side, angle, this angle, and another side, this side, triangle ABC is congruent to DEC. Okay? The sequence in which you label your triangle is very important. They must be corresponding. So A, B, C, D, E, C. If you write DCE or EDC any other way, it will be wrong. It has to be the same. Now back to this, SAS. So this angle must be positioned between these two sides. It must touch these two sides that are the same. Okay, so side, angle, side. So you can't use this angle or you can't use this angle. It has to be the angle that are between these two sides that are the same. Okay, so SAS is not different. It's not the same as ASS. Okay, it cannot be angle side side, or it cannot be side side angle. Okay, it must be side and angle between these two sides. So for part B, you want to find the length of AB. Since we have already proven congruency, we know that AB is equals to DE, so it's equals to 8 cm. The third test would be ASA, angle side angle. Now if you look at these two triangles, as mentioned in the previous test, the sequence is important, right? So this side must be between these two angles. So, but what is given here is angle, side. But does it matter? It won't matter, because once you know two angles in a triangle, naturally this angle will be known, right? Because of the angle sum of triangle. So if this is 100, this is 35, naturally this must be 45 degree, and this must be 45 degree. So for angles, we can be a bit more lenient. We can go angle, side, that's fine. Because if these two angles are the same, naturally the third angle must be the same. So it's really up to you. But we can also go with angle, side, angle, that's fine. So we know that the third angle here is 45 degree. So we know that angle MLN is equals to angle UTV, which is equals to 45. LN is equals to TV, which is equals to 7 cm or 7 units. And angle LNM is equals to angle TVU. Right, so by one angle, one side, another angle, triangle MLN is congruent to triangle UTV. Okay, so part A I've already answered the angles. Part B, state why they are congruent because of angle, side, angle. So this is my part B. The last one will be right angle hypotenuse side congruence test, which is RHS. Meaning that if the hypotenuse and one side of the right angle triangle are equal, then both triangles are congruent. Because in right angle triangle, we already know that one side is right angle, right? So this is just another variation of ASA. So two angles are the same, you just need one side to prove. So in try 4, part A, name the pair of congruent triangle in the figure. So since these two triangles given are right angles, so we just need to prove that the hypotenuse and one of the sides are equal. So DC is equals to BA, in this case 7 cm, and one more side is equal. So DB is the common side. So therefore, by RHS, triangle CBD is congruent to triangle ADB. Okay, part B. We want to find angle X. So angle X will correspond to, because this is CDB, right? So it will correspond to angle ABD, which is this angle here. And ABD is equals to 90 degree minus away 65 equals to 25 degree. So for similarity and congruency questions, you will see all kinds of triangles, whether they are overlapping, vertically opposite each other, or side by side. So it's good to expose yourself to as many kinds of diagrams as possible. So for question 5, prove that triangle ADE is congruent to BCE. So what I have is DE is equals to CE. AE is equals to BE. And because this one is straight line, they intersect, so angle DEA is equals to angle CEB because of, again, the vertically opposite angles. So therefore, you need to state by what test you are using. So by SAS, triangle ADE congruent to triangle BCE. And then part B, you want to prove ACD and BDC. So these two are overlapping triangles. What I know here is that AC is equals to BD, and DC is a common side, meaning DC lies on both triangles. So we have side, side. So we also know that angle ACD is equals to angle BDC because of isosceles triangle. Look, this is isosceles, right? So these two angles are the same. So therefore, what we have is side, angle, side, side, angle, side. Triangle ACD is congruent to, three strokes only, triangle is congruent to triangle BDC. Erase, 3 strokes. And name another pair of congruent triangles and prove their congruence. DB is equals to CA. AB is a common side. Right, this. So the triangle I'm looking at now is this one, which corresponds to this one. So I have DB and I have AB. So again, angle EAB is equals to angle EBA. This is because of isosceles triangle. So this angle is equals to this angle. So again, by SAS, triangle DBA is congruent to CAB. So the last part is, why can't we use SSA or ASS? So I'm going to show you this example here. I have AB is equals to PQ. I have BC is equals to QR. And then I have one angle the same, angle BAC is equals to angle QPR. Now if you look at this, side, side, angle, side, side, angle. Even though all these are the same, you can tell immediately that they are not congruent triangle. Okay, so this one explains why. So this BC, I can totally move here QR. This is a little isosceles triangle, but we are not checking this angle, right? Because we don't check this angle, or we don't check this angle. If we want to prove, remember, it must be angle between two sides, right? So we don't check this angle, we'll never know whether they are truly congruent or not, because we're checking this angle here that are not between these two sides. So the only accurate one would be SAS and not SSA.